Elastic collision in one dimension. Consider two perfectly elastic bodies A and B. So these are two perfectly elastic bodies A and B whose masses are m1 and m2, and they are moving with velocities u1 and u2. Let u1 is greater than u2. After some time, the two bodies collide head-on and continue moving in the same direction. So after some time, they collide with each other and then they move on in the same direction with velocities v1 and v2. This is after collision and this is during collision. Now for elastic collision in one dimension, the characteristics of elastic collisions are, we know the momentum is conserved and the kinetic energy is also conserved for elastic collision. So we will apply that here. First of all, as linear momentum is conserved in any collision, so the total linear momentum before collision will be equal to the final linear momentum of this as a whole. So total linear momentum before collision is m1 u1 for this one, and for B it will be m2 u2. So m1 u1 plus m2 u2, and after the collision it will be m1 v1 for A plus m2 v2 for B. So this is our equation 1. Now let's rearrange this. So it will be m1 u1 and minus m1 v1 if we take this here, and m2 v2 minus m2 u2 will be there. Now let's take m1 common, so it will be u1 minus v1 and m2 v2 minus u2. Now since kinetic energy is also conserved in an elastic collision, so the kinetic energy of A, it will be half m1 u1 square plus B half m2 u2 square, and after the collision it is half m1 v1 square plus half m2 v2 square. Now we can cancel out half, so it will be m1 u1 square, and if we subtract m1 v1 square, so it will be minus m1 v1 square, and it will be m2 v2 square minus m2 u2 square. Now if we take common m1, so it will be our m1, it will be our u1 square minus of v1 square. So it is a square minus b square, that is a plus b into a minus b. So in that case it will be u1 plus v1 and into u1 minus v1. Similarly here if we take m2 common, so it will be m2 v2 square minus u2 square, so a square minus b square, so it will be a plus b and a minus b, so v2 plus u2 into v2 minus u2. This is our equation 3. Now let's divide equation 3 by 2. Dividing equation 3 by equation 2. So our m1 will cancel out, and u1 minus v1, this will cancel out, and similarly m2 v2 u2 and v2 minus u2 and m2 cancel out. So we will be left with u1 plus v1 equals to v2 plus u2. Then we can write it as u1 minus u2 and v2 minus v1. So this is u1 minus u2 is, so u1 minus u2 represents relative velocity of A with respect to B before collision. Since this velocity is u1 and this is u2, so u1 minus u2 represents velocity of A with respect to B before collision, and v2 minus v1 is velocity of relative velocity of B with respect to A after collision. We can also say it as relative velocity of approach, that is u1 minus u2, the difference between their velocities. And after that, since v2 is greater than v1, so it will be v2 minus v1, and this is our relative velocity of separation. So in one dimensional collision, elastic collision, the relative velocity of approach is equals to relative velocity of separation. Thus, we can say in an elastic one-dimensional collision, the relative velocity of approach before collision is equal to the relative velocity of separation after the collision.